Good morning, sir. I am Avnish Nagpal from GIM, and today in this video, I will be creating a machine learning pipeline for predicting whether customer will churn or not churn using an e-commerce dataset. And for pipeline creation, I am using KNIME platform. So let's begin. So the dataset provided is in Excel format, and first I need to import that dataset, and for that I will use Excel reader, and I will drag and drop Excel reader from nodes, and then I need to select my data set. So okay, browse, then desktop ecom assignment and e-commerce customer churn data set open. So yeah, the data set is selected, and here we got a mini preview of the data set. And here we can see we have a lot of rows and different attributes like customer ID, churn, tenure, preferred login device, and obviously churn is our target column. So we can apply and okay, then I will execute this node, and yeah, it got executed, and we can see we have total 5,630 rows, and total number of columns are 20. So in stats, we can see different mean, median, mode, and different quantiles of all our columns. So of all our numeric columns, and also we can see from here, then there are missing values present, like in tenure there are 264 missing values are there, and in warehouse to home there are total 251, and we have other columns as well with missing rows. And also we have several categorical variables, but they are their type is in number. So we need to change these into string type, and the columns we need to change our churn and and city city tire. Yeah. So these we need to transform these columns, and for transforming these we will open dialog, and we will go into transformation tab, and in churn we will convert it to string, and also the city one also into string. Yeah. So then apply, okay, and then we will again execute this node. Yeah, and we can see in stats that our churn type is now string, as well as city one also type is string now. Perfect. Now in table we can see we have 20 columns, and we have one column with customer ID, which is not required in this model because firstly, this column has high cardinality, and also for each, like it doesn't make any sense of using this column. So we need to remove this. So, and also if we see these red question mark, these all are missing values. And also we also already checked in stats that there are a lot of missing values are present, and we can see from here, like we have about 264 missing values in tenure, and 251 missing values in warehouse to home, and 255 missing values in hour spent on app. Then we have 265 missing values in order amount hike, and 256 in coupon used, and 258 in order count, and 307 days since last order. So the best way to treat any missing values is to remove those rows. And if we add these rows, like it's 264 or 251, it's like some in about 1800 to 1900 rows. So the best solution is to remove this, because after removing these rows we will be left by almost 3000 rows, which is enough for our model training and model creation. So now we will start a data cleaning part. And first in the first part, I will be removing this row, and for that I will use column filter node. Yeah, here is column filter node. I will input the data. Yes. Then I will exclude the customer ID from here and includes all other columns. Then apply and execute. Yes, so we can see our one column get dropped and the value changed from 20 to 19, and there is the column ID gets removed. And now we need to treat the missing values and we need to filter all the rows. And for removing those rows, I will be using row filter node. Yeah, here it is row filter node. And from column filter, I will take the data into row filter, and here I need to add a filter criteria. And first the missing values were in tenure, so I will select the column tenure, and in the operator I will select is not missing. So here I'm selecting the filter like I only need the rows in which there are no any where there is no any missing values. And in output I need retain and output matching rows. Then I will execute this node, and then I will check in stats, and in tenure, yeah, I don't have any missing values. Now the missing values next column is warehouse to home, and then is our spend on apps. So next we will treat these two columns. So again, I will drag and drop row filter. Oh, I will input the data, select warehouse to home, and then is not missing. Then same output, then apply and execute. And then again check in stats. Yes, so there are no missing values in warehouse to home column. Then next turn is to treat our spend on app. So again, I will drag and drop row filter, input the from previous node, and then add filter criteria, and then I will select our spend on app is not missing, then apply and execute. Yes, so missing values are removed from our spend on app as well. So now missing values are in order amount hike, coupon used. So first I will remove from order amount hike. So again I will drag and drop, take input from previous node, then select order amount hike is not missing, apply and execute. Then in stats, again we will check the next column. It's coupon used and then order count and day since last order. Yeah, only three columns are left now. So coupon used. Now for coupon use, same steps as previous one. Add filter criteria. Coupon used is not missing. In output, retain and output matching rows. Apply and execute. Then again for order count and day since last order. Order count is not missing. Apply and execute. And now for day since last order is not missing. Apply and execute. Now we will again check in stats. So in the missing values and columns, so yeah, so all the missing values are treated, and there is no any missing values are present now. And currently we have about 3,774 rows and total 19 columns. So our data set is treated now. The data set is clean now. Now we will start the EDA part, and first we will check whether our data set is balanced or not. And for that, we can use pie chart, and for that we will use pie chart node. Yeah, here it is pie chart, and we will input our data to pie chart. And in category dimension we will select churn, and in aggregation we want to count the number of churn and not churn, so we will select occurrence count. And yes, threshold would be 3. And yeah, sort categories by size category is, yeah, other things are fine. Then apply and execute. Okay, so we can see our churn is 16.72% of the dataset, and no churn is 83.28% of dataset. Usually, if the dataset is, if any category is less than 20% of all dataset, we generally consider it as imbalance. But it's 16.72%, so it's slightly imbalanced, not completely. So we can go for our model creation with the same data. So there is no need to create any synthetic data. So that this is fine. So now we will check whether any outliers are present in our columns or not. But before that, there are a lot of nodes for data cleaning. So I will make a meta node for all the data cleaning nodes. So I will select all, and I will convert all these steps into a single node by using create meta node and confirm, and name this data cleaning node. Yeah. And then again execute it. Yeah. And pie chart here. Let's zoom little bit. Yeah. Okay. So now we will check whether any outliers are present in a dataset or not. So for that, we will use box plot. Yeah. And drag and drop box plot node and input data from data cleaning node, and we will include all the columns and then apply and execute. Okay, so here we can see the box plot of different columns, and we can see one and two outlier present, like in tenure one outlier is present, in warehouse to home one outlier is present, and several outliers are present in cashback amount. So we need to treat these outliers, and the best way is to remove the rows. And for that we will remove the outliers which are greater than 1.5 of IQR. And for treating this, we will drag and drop. We will use numeric outliers node, and we will select numeric outlier. Yeah, this one. And we will take data from data clinic and yeah, input into numeric outliers. So now we need to remove those rows which have outliers, and in treatment option we will select remove outlier rows, and then apply and okay, and then execute. Yeah, so we can see that uh, we can see the outliers are removed, and our rows now our rows are about 3,000 and columns are 19. So let's check again whether the data is balanced or not, because few rows are again removed. So again, we will select a pie chart from here. And yeah, then again, I will put the treated table in this pie chart and select from category dimension churn, right? Occurrence count, and then apply and execute. And yeah, so percentage is almost same like the previous one. So we can continue with our model creation. So data is slightly imbalanced, but we can use this. So the next part is to encode our categorical variables. And for that, we will be using one hot encoding. And for doing that, we will use one to many node in KNIME, one to many. Yeah, one to many node, and we'll drag and drop this and take the treated table data from numeric outliers and input into the one to many. And in open dialog, so here we get option which columns to exclude and which columns to include. And we need to, we, we doesn't want to one hot encode the churn column because it's a target column. So we will exclude this, and other column we need to encode. So we included all the other columns: preferred login device, city tire, preferred payment mode, gender, preferred order category, and marital status. Now we will apply this and click on OK and then execute. Okay, so we can see columns increase to 43, and for all the categorical variables except churn, the values are encoded. Yes, like city for city three, tier three, for one, for two, all are encoded. For preferred payments, we have UPI, credit card, cash on delivery. So our category variables are encoded, but now we need to remove the original columns from this, because we can't use both the encoded one as well original one for our model creation. So for that, we need to remove these columns, and for that we will use the column filter here. So again, I will select the column filter, drag and drop this, take data from one to many into column filter, and then I need to select the column which I need to exclude. So I need to exclude preferred login device, then city, then preferred payment mode, then gender, preferred order category, then marital status. I think others are, yes. I need to exclude these columns and include all the other columns. So then now I will apply and execute this node. Yes, now our columns number decreases from 43 to 37, and total number of rows we have to about 3000. So now the columns, now our data set is clean. Now the next part is we need to normalize our data set. And for that, we will use normalizer node. We will search normalizer node from here and drag and drop it. And then we will take the filter table data from column filter and put into normalizer. And then we need to normalize all the columns, and the normalization method I am using is min and max. And there are other method as well, is z-score and decimal scaling, but I will be using min and max, in which minimum value is 0 and maximum is 1. So now I will execute this node. Yes, so all the columns are normalized between 0 and 1. And now the next part is to partition this table into churn into the next step is to split this table into training and testing set. And for that, I will be using here table partitioner. Table partitioner. Yes, I will drag and drop this. Mm, Take the normalized table data and use in the table partitioner for partitioning into training and testing set. So in table partitioner, we need to select the sampling strategy. So by default, it is random sampling, but as our data set is imbalanced, slightly imbalanced, and with churners being a small minority, and if I use the normal random split, it could accidentally create a training or test set with very few churners. And to avoid that, I will be using stratified sampling. So I will select stratified sampling from here, and the group column I will select churn, and yes, I need the random seed as well, so that every time I run this pipeline, so I get the same set of rows in training and testing set. So I will select this fix random seed and then apply and execute. So the output we got is first partition and second partition. In first partition, we have 70% of data and the number of rows are 2060. And in second partition, we have about 883 rows. So this first partition data I will be using for training my model, and for second partition I will use for the testing the data, testing of the model. So now for creating the customer churn model, I will be using a logistic regression classification model, and for training the model, I will use logistic regression learner from the nodes and drag and drop that nodes. Yes, logistic regression learner, and put the training data, the first partition, into this for training my logistic regression model. And then my target column is churn, and the reference category is one. I'm assuming the churn to be one, so I will select the reference category one. And for feature selection, I am selecting all the feature because I already cleaned the data set, like I removed the column ID already. So there are no need to exclude any column. So I will be including all the data set, all the columns in the data set. So now I will apply this and OK, and then I will execute this. So yes, our logistic regression model is trained, and in this coefficient and stats, we can see the all the variables which are used for training this models with the coefficient values of each variable, and also we get the standard error and z-score and p-value. So now our model is get trained. So now we need to check the uh, we need to check how our model is performing, and also we need to check whether it's predicting right or wrong. So we will use a logistic regression predictor for this. So we will select the logistic regression predictor here. Yes, then we will input the model for predictor and give the our testing data, which is a second partition, into this. And then we open a dialog and we will name this into predicted churn. And also we need the probabilities uh, of all the rows, so that we can check whether it's predicting right or not. So checkbox all both the options and then apply and OK, and then execute logistic regression predictor node. Yeah, so we get this output, and we can see that for first three rows, the actual data is 100, and the model predicted is also 100. And here is the probability of churn, and we can see the values which is greater than 0.5 is classified as churn, and values which is less than 0.5 is classified as not churn. So 0.5 is our threshold. So now we need to check how our model is performed, and we need to create a confusion matrix for it, and also check various other classification metrics like accuracy, precision, recall, F1 score. And for that, we need to drag and drop scorer node. So here is a scorer node. So yes, so I will take the input from predicted data and put into a scorer, and then also I need to select my actual, the first column is churn and second is predicted churn, and then apply and then OK and then execute. Now we get the confusion matrix in this where one is churn and zero is not churn. And also these are the prediction which the model did, and these are the actual values. So so the vertical is the prediction and the horizontal is actual one. And in we have several accuracy stats and metrics, like we can check the accuracy of the model, and it's coming 0.907, which is a very good accuracy. And also if we check the precision and recall for churn, the recall is 0.589, and for the recall is 0.589 and precision is 0.796, and F1 is 0.677. So for the case of churn, we will mostly check the recall, and the recall is 0.589. So and the overall accuracy is 0.907. So our pipeline is created. So I will give a summary like what we did. So we firstly we imported the data using Excel reader because our data was in Excel format. Then we cleaned our data, and for cleaning the data we first removed the customer ID column, and then we remove all the missing values in different columns, and then we take the output, and then we started the EDA part. In first we check whether the data set is balanced or not, and then we also check whether outliers are present or not, and we found that outlier was present, and then we treated those outliers using numeric outliers by removing those rows. And then we again checked whether data set was balanced or not after removing those rows as well, and we found that data set was in the similar percentage as previous. Then we encoded our string attributes, and then we remove the original columns or string columns which we encoded in the last step, and then we normalize our data using min max normalization method. And then we partition our data into 70/30 ratio uh, into training and testing part using stratified sampling. And then we trained on model. I am using logistic regression learner here. And after training that model, I also tested this model, and then I checked the metrics, and in the last we get the confusion metrics and the accuracy of 0.907. So this completes our all pipeline from data loading, data cleaning, EDA, data preparation, data splitting, model creation, model evaluation. So yeah, this is the pipeline, nine pipeline for predicting whether customer will churn or not churn. So yeah, thank you, sir. Yeah.